Okay, another triangle congruence theorem. So far we've learned that if we have two triangles, this is from the last lesson, angle side angle, it said that if we have two triangles and we notice that one angle along with another angle are congruent to each other along with an additional side, an included side, then the triangles are congruent. Now, in lesson 5.3, we're going to learn a new theorem, SAS, which says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So this looks like this. So it's kind of the same thing. And notice we have a new vocabulary word, included angle. Before it was an included side. Now it's an included angle. So we have two congruent sides. Let's say this one and this one. So two congruent sides, this one and this one. And then an included angle, we have to make the angle included, so it needs to be in between the two sides that are congruent, like that. So I want you to notice that these, if I were to do this again, but have a non-included side, it would be a side, any of the sides that are not in between those two sides. So we'll just keep it like that. So two congruent sides, and then in between an included angle. So example triangles that are congruent by side angle side congruence theorem, we have that JL is 46 inches. So I'm going to put a little congruent mark because I have one that's 46 inches over here. So JL is congruent to PM. That's another way of saying that. Remember that little mark? And then JK is 74, and also NM is 74. So they're congruent to each other. I'm going to put 2 marks on those ones. JK and NM are congruent to each other. And then we also have the angle J is 37 degrees and angle M is 37 degrees. So those are both congruent to each other. So this is setting me up for ASA. Explain why triangle JKL and triangle NMP are congruent. Because JL is congruent to PM, JK is congruent to NM, and angle J is congruent to angle M, and they are included angles. Okay. Examples of triangles that are not congruent. Okay, so we have AC is congruent to DF, and then EB is congruent to ED. I put 2 marks on these because they're 2 separate sides that are congruent to each other. But then I have that this angle A is 43 degrees and angle D is 45 degrees. So explain why they're not congruent. We're going to say because the included angles are not congruent. There you go. Okay, so here we go. Determine whether the triangles are congruent. Explain your reasoning. So I want to give you a second to take a look at this. See if you can figure out if they're congruent or not. And remember, we're using SAS. So we want to determine if we have any sides congruent. So if we take a look at this one, we see that DE is 2.5. What's the other side that's 2.5? HG. And then we also have these are 1.7. And I don't know if this side is congruent because I don't have HJ. But I do have that angle D is congruent to angle G. It just told me that. So can I say that the triangles are congruent? Oops, I should put 2 marks on these. Yeah, I can. Yes, because DE is congruent to HG and DF is congruent to JG. Also, angle D is congruent to angle G, and they are included angles. We can say, so by SAS, triangle DEF is congruent to triangle HGJ. Usually I write that the other way around, but it doesn't matter as long as it says SAS and also the triangle congruence theorem. Okay, determine whether the triangles are congruent. Explain your reasoning. So I'm always going to, in this lesson, I'm always going to be using SAS, so it needs to look something like, both of the triangles need to look something like this, somewhere. Okay, so I have PRS right there, and I have that this side is 2 inches, and this side is 2 inches, and then I have, it just gave me that angle P is congruent to angle R. Nope. I want you to focus in on one triangle, just PRS right here. If you just focus in on this one triangle, I want you to determine if you can set this picture up right here. So if this is a congruent side and this is a congruent angle, what side would I need to be congruent to make that angle included? The side that's right next to that angle, right? I would need this side to be congruent. So now if we look at the other triangle, can we actually say that that side is congruent to the that side in the other triangle? I think we can, right? Because they share that side. So PR is congruent to PR. So we're going to do PS is congruent to, we can set it up the way that we did ASA. So we're going to say SAS, the side PS is congruent to QR. The angle P is congruent to angle R. And remember that angle that you choose, it has to be an included angle. So if it gave us angle S is congruent to angle Q, that would not be SAS. Okay, so keep that in mind. And then the next one, angle side PR is congruent to side PR, which is obvious. It's the exact same side. Okay, take a look at number 3. I want you to pause the video and try to set it up. Try to set up, okay, sorry, one more thing. Triangle PRS is congruent to triangle PRQ by SAS, triangle congruence theorem. Okay, this is important. You need to make that statement. Be able to say why they're congruent. Okay, now set this one up. See if you can use SAS. I like to start by marking it up, so I can say these are congruent to each other, these angles are congruent to each other. What else can I say? This side is congruent to each other, the one that it shares. Is that set up for SAS? SAS, it sure is. Alright, side AB is congruent to side BD. The angle that's congruent, let's use 3 letters on this one. ABC, angle ABC is congruent to angle DBC. And then the other side, BC is congruent to BC. Triangle ABC is congruent to triangle DBC by SAS. 4. You check this one out. Determine if you can use SAS. Pause the video. I want you to be thinking about it too. So pause the video, figure out if you can determine if these triangles are congruent in number 4. So I'm going to show you the answer in 5, 4, 3, 2, 1. So I have these sides are congruent, ED and HG, EF and HJ, but do I have the angle in here is congruent? Well, this means that it's 90 degrees, right? And this angle right here is 95. So I can't say that they're congruent. So I'm going to say angle E is not congruent to angle H. No, so not congruent. Because angle E is congruent to angle H is not congruent to angle H. Okay, number 5. Think about this one. Pause the video again. I'm going to tell you the answer in 5, 4, 3, 2, 1. First, I noticed that CB is congruent to BD because they're both 1.3. Then I noticed that they share a side, so AB is congruent to AB. And now I need to figure out what angle needs to be congruent for us to be able to use ASA. Is it going to be this one? No, right? Those angles aren't included. So it's got to be here. These two angles. Angle ABD congruent to angle, I'm running out of room, angle ABC. And can I say that? I sure can, because they're both 90 degrees. Alright, so triangle ABC is congruent to triangle ABD by SAS. Okay, next one. A little different, but using the figure, fill in the missing information needed for triangle RST to be congruent to triangle LMN by SAS. So you are going to have a question that's similar to this on your quiz, so I want you to pause the video and try this one out. See if you can get it. I think you can, because we've looked at these a couple times. So it needs to be congruent by SAS. What does the value of X and Y need to be? I'm going to show you the answer in 5, 4, 3, 2, 1. So X would need to be 5 centimeters. They'd need to be the same. And also Y would need to be 90 degrees. Okay? Simple. Okay, next video for lesson 5.4.